So we're going to start with calculating payments, calculating annuities, calculating how much would your payment be if you decided to buy a house, or if you decided to buy a car, or you want to make a loan and you want to make regular payments, what would it be? So we're going to calculate this according to formulas that we're going to learn, and basically that's going to help you, right, in the future. If you decide to buy a house or buy a car, you'll be able to calculate your own payments and know what you're doing. Now, before we start with what we call the annuity or the regular payments, I wanna go over the two formulas that we have seen like the day just before the break. If you guys remember these two formulas. These two formulas, technically, you should know them from grade 11. Okay. So the formulas, if you recall them, that's right, the decay and the growth. Right? So if I'm looking for the future amount, so that's your future amount equals to your principal 1 plus I to the power of n. Okay? So this we use if we have compound interest, right? Remember, compound interest is interest on the interest, right? So if you're the question will tell you it's a compound interest. Okay, so you have to use this formula if you're looking for the amount. Right? And if you're looking for the principal, so you're looking for the current amount, today's amount, it will be P equals A1 plus I to the power of negative n. Okay? So these two formulas, they are used when we have compound interest okay? But it doesn't say that we have a regular payment. Okay? It will not say that you have a regular payment. That's just one-time thing. Okay? So let's say you put in the bank $1,000 and you leave it. Okay? You do nothing to it. You leave it. The bank is giving you some kind of interest, compounded, let's say monthly, right? And then you want to know how much you'll have after 10 years, for example. That would be one question. Okay? Now, what we're going to look at today is a bit different, okay? Because we're still doing compound interest, but we're doing things that we're adding money to it. We're not only putting $1,000 in the bank, we're putting $1,000 every year, let's say, okay? And we're earning money. So we have a regular deposit or a regular withdrawal that we are adding or we are taking out of the account. Okay? So it's not as simple as this. Okay? So let's see what happens. So we call it an annuity. So we're going to start by calculating the future annuity. Okay? So what happens in the future, later on? Annuity. No, annuity means it's a series of equal payments paid into or out of an account at regular intervals. Okay? So think about it this way. You have a mortgage, right? Mortgage, you have to pay every 2 weeks, you have to pay a certain amount. Let's say $1,000, just to make it easy for us. Okay? So every 2 weeks, you have to make $1,000 payment. That is your regular payment. That's your annuity. That's called an annuity. Because every 2 weeks, you're paying exactly the same amount. Do you understand that? Yes. Right? On your car, you buy a car, you finance it, right? Same thing. Okay? So the important part here is that you have you're making a series of equal payments, okay? It could be a payment or it could be a withdrawal. It's a regular, at regular intervals, okay? So same amount, exactly. In an ordinary simple annuity, payments are made at the end of each compounding period, okay? So basically, let's say if you are making it compounding bi-weekly, so at the end of every 2 weeks, you make your payment, okay? So that's the first 2 weeks, at the end of that, you make your payment. 2 weeks, at the end of that, you make your payment. 2 weeks, right? And this is all what we are gonna do in this course. It's called ordinary simple annuity.
It's the same like in the first one.
Yes, yes, but there's other ones that are not ordinary simple, then they don't make the payments at the end of the 2 weeks, or at the end of the period. Now, when the question is asking you, what is the amount of that annuity? It's asking you how much money do you have at the end, okay? So let's say you decided you want to save some money for your education, okay, or for your son's education, or what, okay? And then you decided that right now I'm gonna make $100, I'm gonna deposit $100 into a bank account every month. And the bank is gonna give you interest on that, right? So at the end of the year, you're gonna have $1,200 because you made these $1,200, right? You put them in the bank account. But on top of that, you're gonna have the interest that the bank is giving you. The first month, the bank is gonna give you interest on the $100. Second month, the bank is gonna give you on the 200 and the interest that you earn on the first 100, right? The third month, you're gonna earn interest on the 300 and the interest that you earned on the 200 and somewhat, okay? So it's kind of accumulating, it's kind of getting bigger and bigger, okay? But we have to keep in mind our regular payment that we are making, that $100 that we are putting in. Do you guys understand that part? Okay. Now the compounding period it's the same as what we have been talking about before, right? So if it's annually, it's once a year, right? So it's 1. If it's monthly, how many times would that be? 12. Probably should go this way. How about if it's semi-annually? 2 times a year. Monthly, we said it's 12. Semi-monthly?
Semi-monthly, bi-weekly?
No, semi-monthly is different than bi-weekly. How many semi-months do I have? 24, right? I have 12 months a year. If you're doing every half a month, that's 24 times. How about weekly? 52. How about bi-weekly? 26, because I have 20, if you divide 52 by 2, that gives you 26. How about quarterly? 4 times a year, right? Daily?
365.
65? 65.
I have this problem, right?
Okay, now, why do we need these compounding periods? Because when we're dealing with compound period, we always divide the rate by the compounding period. So to find the I value, you always have to take your rate. So let's say if your rate was 5%, which is 0.05. So you divide your rate by your compounding period. I'm going to call this big N. Okay? So it's going to be R divided by big N. And to find N, the small n, right, you have to multiply the number of years by your compounding period, by big N. Okay? So let's talk about, actually we're gonna look at an example. Why did I write this here? I probably could have wrote it right here. Okay, so let's look at the formula. So the amount of an ordinary simple annuity is given in the formula A equals R, that's your regular payment, bracket 1 plus I to the power of n minus 1 divided by I. Okay? So where R is your regular payment. So this is how much you're putting in every month or every whatever, or how much you're taking out.
Initial.
It's not your initial amount, it's how much it's your regular payments.
Okay.
Okay? So let's define the letters. So A is your future value. So how much would it be worth, right, in the future? R is your regular payment amount. I is the interest rate in decimal per compounding period. So as I wrote earlier, right, I is your interest rate, which is R, but it should be in decimal, so you should change it to the decimal. And you divide by your compounding period, which is, we said it's big N. We're going to call it big N. And N is the number of compounding periods. As I told you earlier, you have to, if it's not in the, so let's say if you're compounding monthly, and I give you that you're doing this investment for 3 years, how many compounding periods is that?
3 years. So it's 36.
36
months, yeah.
36 months, because you're compounding monthly,
Monthly.
right? So you have to multiply the number of years, right? So that's the number of years times your big N. Now, if it's already given to you in month, you don't do anything, right? If I already told you you're doing it's compounding monthly and you're putting it for 36 months, you leave it. It's already in month. You don't need to do much. And as you probably can, as you can see, the formula can only be used when the payment interval is the same as a compounding period. This is what we're gonna only do in this course, right? Where you have the same payment interval as your compounding period. So you're paying monthly, and your compounding period is monthly as well. Okay? Otherwise, it's gonna be much more complicated. So suppose $450 were deposited at the end of each quarter for 1.5 years into an annuity that earns 10% per year compounded quarter. So what am I doing here? What am I doing? What's the scenario? What am I doing? Explain to me. Go ahead.
It's like maybe like it's like a rent or something like that, and it's compounded, so the probably be C equals P bracket 1 plus I bracket N.
How am I making a regular payment or a regular deposit? Right? What's my regular deposit?
450.
What do we call that? What letter? R.
R.
R. Right? Because that's your regular. It does say deposited at the end of each quarter. Right? This is how you know that it's regular payment, because at the end of each quarter. Right? So, okay, good. So I know that this is my regular payment. Right? So I'm depositing $450. Every quarter. Good. How long am I putting that into an account? So for how long am I doing that?
1.5 years.
1.5 years, right? So basically that's my number of years, but I have to find my compounding period, right? I don't know what my compounding period is. Well, I do know, but that's not N, right? Because N should be this times big N, right? What's my compounding period? Quarterly, that means what?
4 times a year.
4 times a year. So I have to multiply this by 4, right? Now, what's my interest rate?
10%.
10%. How would I find that to find I? What would I do to find I?
We have I is R on divide by N.
So this divided by your compound.
Yes.
Okay, so let's write them down. So the question is asking what is the amount? So I'm looking for A. I don't know what A is. I don't know what A is. I know that R is 450. Small n is 1.5 times 4 because I have compounding quarterly. So what is that? 1.5 times 4. 6. And then my I is, so 10% is 0.1 divided by 4, right? Remember that your I, you divide the rate by the compound period. So what's 0.1 divided by 4? 0.025. Okay? Now I have everything I need. All what I have to do, I have to plug them in the calculator. Okay? I have to plug them in the formula. A equals R1 plus I to the power of n minus 1 over I. I want you to try to put this in the calculator just to make sure that you get the same answer as me. Want everyone to try this on the calculator. when you're writing down money, money has to only be to 2 decimal places. Okay? So you make sure that you round properly to 2 decimal places. Got it? So it should be $2,874.48. Now, the second question is asking you how much interest did the annuity earn? Just think for a second with me and tell me how would you be able to find it? So you earned $2,874.48. How much of that $2,874.48 is actually interest? No, I want to know like in dollar amounts.
Maybe more is R, because the money that I
So you, what is R?
is 450, per 12. I get the amount that I
Why per 12?
It's 40 by 4. Just to know the amount that I put it in bank for 1 year.
Why 1 year? How much did you put your money in the account?
Which month? Which quarter?
How much did you put in?
Oh, in 1 year and a half.
Okay.
Yeah, I know to know what my the money that I put, and the difference is the interest that I get from this amount.
That's right. So how much money did you put in? Right? You didn't only put one 450. How many 450s did you put?
Yeah, for 1 year. It's
How many? 6 times.
6 times, yes.
You made 6 payments of
Yes.
450.
Yeah.
Right? So that is your R times your N, your regular payment times your N, right? If you take away your full amount, take away how much you put in,
I will find the interest.
that will find the interest. That's right. So it's A minus RN, but even if you don't remember the formula, you should kind of use your common sense, right? You're making, your amount is $2,874, right? You're making $450 payment 6 times, right? So this is how many times you have, you made the payment. So the answer should be $174.48. Something that I forgot to do on the top is I forgot to put a therefore statement, which you should not forget to do that. So at the end
Of 1 year and a half.
of 1.5 years, the annuity is worth and then at the end here, you have to say that the interest earned or the annuity earns